Hello everyone, welcome to the streams part 3 lecture. Today's lecture, we are going to cover we are going to see in action a lot of methods which Stream API provides. Last 2 lectures were dedicated to the basic concepts of Stream, like what are streams, what are their usages and all. Today, we're going to see the strings in action. Actually, how do you code using different methods? So if you remember from last lecture, we saw this kind of image where what we will see is we have different transactions. We create a stream, we filter the transactions, get only those transactions which are of type groceries. We sort them, then we get the IDs and we return a list of IDs. All right. So basically the use case is you have a bunch of transactions from which the requirement is to return the IDs of the transactions which belong to groceries, the transactions which are of groceries. Okay. Let's see this in action. What you have is here in this class, this is a demo class. First of all, this is a lecture about intermediate operations. We have to cover the terminal operations, but that's not the focus of this class. This lecture is specifically for intermediate operations to show what different operations do. So for that example, we have transactions. So basically, we have a transaction class. It has three attributes: ID, value, and transaction type. Boilerplate code, getters, the constructor. We have a transaction builder, which will build a transaction for us and return it. Okay. In the demo class, this is the method gets transactions, which uses the builder, builds transactions of different types. So 2 are of grocery, 1 is entertainment, 1 is travel, with these values, and returns a list of all the transactions. And before we begin, so what is our use case scenario? Or what is our example here? First one. Okay. Supposing if we need to find all the transactions of type grocery and return a list of transaction IDs sorted in descending order of transaction value. Only grocery types which are in the descending order of the transaction value. Now, before streams, how did we do this? So from here it starts. It starts from here. We first will create all transactions. We get the transactions. Then we get all groceries transactions, right? We add it in the groceries transaction. We iterate over each transaction, check if the transaction type is grocery. If yes, we add it to the grocery transaction list. Then we sort the grocery transaction list by passing a comparator, because that was the requirement. First is get all the transactions which are of type grocery. We want it in the descending order of transaction value. So here we are passing a comparator, which will compare and return the value. So descending order means first we are comparing T2 to T1, okay? And then after that, what we are getting is transaction IDs from the grocery transactions. What we do is we traverse through each, and then we add to the new list, we add the transaction IDs. Such a long list of codes. And then all those, we are printing it out. We are printing out the transaction IDs. Imagine so much boilerplate code we need to do. The longer the lines of code, the more the maintenance, right, of the software. The developers not only code it, but also maintain the software. Not only which you write, but what others write too, right? That's the fact of a developer's life. So if lesser number of lines, which means you have to take care of or manage lesser number of lines. So after streams, see how this so after streams, what you see here is, see the reduction in the number of lines of code. We will go through what each one does, but just see, imagine before streams, the number of lines that we have to maintain, and after introduction of streams, how compact and elegant the code looks, right? Let's go through one by one. First, let's see it in action, what it does. So I'm printing it out here and I'm printing it out here. So hopefully both of them print the same value. Let's see. See, 1 and 3, 1 and 3, right? So both the transaction IDs. So 1 and 3 are nothing but 1 and 3 are the transaction IDs, okay, in descending order of transaction values. So as you can see, 1 is 100 and 3 is 80, right? All right, so now we have established both are working fine, gives the same output, same result. Now see what happens. So first statement will remain the same. This part, this will still be the same. We are processing through the same list of transactions. What we do next is we want only those transactions which are of grocery type. So the method filter, what it will do is, it's an intermediate method. So this will return a new stream. Return a new stream. And now the stream, what all the transactions that match this criteria will be gathered and passed on to the next intermediate method, which is sorted. Again, just as the name suggests, what will it do? It will sort the transactions that are coming to it. It will sort it based on the comparator that you're passing. Our requirement was, again, descending order of transaction value. So we are getting the transaction value, we are invoking the method get value and reversed because we want it in this descending order. Again, this will return stream of transactions of the transaction type. Okay. Now, what do we want? We don't want a list of all the transactions. We just need list of IDs. How will we get the IDs? For that, we invoke the map function. What it will do, it will get all the input that is coming. So obviously, this is returning a stream of transactions. So on that transaction, what this is doing is mapping it to another value, getting some value, some field's value out of the objects that are coming from the incoming stream, and then collects all the values, creates a stream of integers. See, IntelliJ is giving you a hint. So because ID is integer, what it will do is, again, it is intermediate operation. So it will return a stream, and then this is the terminal operation. This will, so just writing it here, this will return stream of integers, which are nothing but transaction IDs. What we do, pass it to the collect method. Now this collect is a terminal operation. So what we are doing is, because we need a list of transaction IDs, we do it here, collect as to list. And what we are doing it here is just printing it out. And again, look at the print example. So here we had to traverse through each IDs and print it. Here what we are doing is taking these IDs and printing it out, creating a stream out of it, and then printing. So this is like a lambda. What happens is each value that goes in gets printed out. Okay, so this is nothing but integer. So the integer that are coming in get passed out. This for each is again another terminal operation. And here, see, it's IntelliJ is giving us a different hint. So let's see what it is doing. Oh, TIDs for each. So, okay, we don't need to call for each because list has internally it has for each method. Now here, if our objective was just to print, so here the collect is one method, terminal operation. After this, once the compiler reaches this, it will invoke all the other previous methods, the intermediate operations. Because if you remember from the past lectures, the intermediate operations are lazy. They are invoked only after the stream invokes the terminal operation. Now this, if we just have to print, we don't even have to do this. We could directly, the terminal operation, what we could do is dot, we can call for each here, and then just do same thing. And we don't need this line. So again, for each again is a terminal operation. So was the list. So this does not return any value. If you see the definition, it's a void method, a method which where return type is void. So we do not assign any value. Let's run this again. And hopefully still the value is same. Yes, 1 and 3, 1 and 3, right? So now let's get rid of this. Now that we have seen how efficient streams are, we don't need this. And now we will see some more intermediate operations examples. One we saw collect for each. So now sorted we saw, filtered we saw, map we saw. There are some other operations. So say for example, limit. There is a limit. Now if you do here, so let's say if your transaction sizes was, if your transaction sizes, say billions and billions of transactions, you don't want to process everything, you can limit it. So what will happen is now, no matter what, only one will be passed. One element from the stream will be passed. So here, let's do 2. Okay, so we are limiting 2, which means we need only 2 elements from the stream. So limit will return the first 2. So let's see. Let's run this, what it returns. So see, only 2. And now if you see the first 2, only one is of type grocery. The second one is of type entertainment. If we do limit 3, then we'll again get the grocery. So that's the limit. Again, 1 and 3. So it took the first 3. Okay. So limit is useful when you have a huge streams, like billions of streams or billions of collection items in the collection on which you want to create the stream. So limit is useful for that. Next up, what we can do is distinct. Or rather, let's do another one. Similar, opposite to limit. Let's say skip. Skip, what it does it skips from the beginning, it will skip 3. So now here we don't have any transaction. So let's say skip 2. So this guy is going to skip the first 2. So hopefully we get only 3 because the third one is of type grocery. So let's see. See here, 3, right? So that's the ID. So what it does is skips the specified number of elements from the beginning, from the start of the string. Okay, so it skips. Limits, again, but here now again there is a difference. So skip, the major difference, limit will pass. So let's say there was limit 3. All the other, this one will have or will be processing a stream which has 3 transactions, right? Because we said limit 3. Skip will only skip the specified number of transactions and pass the others. Now, in our case, we have only 4 transactions. So it will skip the first 2. And now this, when it comes to the filter, the stream will have 3rd and 4th. And if there was one more, so let's add one more here. So if we add one more, let's say of type 5, which is again, assume, let's say, because we are dealing with grocery, let's do it for grocery, and value is, let's say, 99. Okay, so add D5. So the difference would be, so it will skip only the first 2, and the sorted, when it comes to sorted, will have a stream which contains transaction T3, T4, and T5. Okay, so that's the difference between skip and limit. Skip will only skip the beginnings, the specified number, and the rest all will be passed. Limit will only pass the number of elements that you specified in the limit. Another example, say find any. Okay, so find any is a terminal operation because it does not return a stream. Now here, what it does map transaction ID. Here, let's get rid of all these and dot find any. So see, if you see its return type, it returns an optional. Why optional? Because it may or may not have any if the stream is empty, or if none of the elements are of type grocery, then there will be nothing matched, right? So let's see, find any returns an optional. And then what we can do, since it returns an optional, if present, okay, what we do is say system dot out. So let's pass, because it's a transaction, optional transaction T. So what we're going to do is system dot out dot println, say T dot get ID. So let's see, any means it should return the very first one which it finds. So let's see what it prints. Oh, because it's skipping 2. That's why when it goes here, it skips 2, comes here, found 3. So that's the ID 3. Now, if I remove the skip, it should print 1 because the very first one is of type grocery. See, now we are not skipping, so it starts from the beginning. So this is find any, which returns a transaction, which returns an optional. Now, let's say you need to get total of all the how much did you spend on groceries. So let's say if you want a total of how much did you get spend on groceries. So first we need to filter what you need to sum. You'll have to sum the values, right? The transaction value. So then what we do is map, but we cannot do just map. I'll show you. This one would be an error. Let's see. So if we map, this one won't work. So transaction.getValue dot sum. See, there's no method sum, right? Because this returns a stream, okay? A stream of transactions, and transaction doesn't have a sum value. But integer stream has some method. So what we can do is we can convert it to an integer stream. And now if you see, there is a sum method, right? So this sum would be a total of, so this would be int total spent on grocery equal to this. And if we print, we'll see how much we spent. Let's run this. So 279. So we have 3 items here, 100 plus 80 plus 99. So 279. Okay, so this is the sum. Now here, see the difference. mapToInt. So returns a different kind of stream. So if you look here, int stream, the return type of this method is int stream. And if you look at int stream, it has all these methods, sum, range, different values. We'll cover it when we come to int streams, or you can look it up in the API. It has different methods in it. Int stream, double stream, long stream. We have different types of streams with specialized methods in them. So this is getting a sum of how much you spend. Then another one that you could do is count. So let's say if you want how many transactions, not value, but you want how many transactions were of groceries. So you could just do count here. What does it say? Required type int, provided long because count returns a long. Here it is. Okay, so how many are there? 1, 2, and 3. So it should return 3. Or let's do just, instead we are stuck on this thing. So let's do travel. So it should return 1, right? So I'm just going to say total transactions. Okay, which are of type travel. So the expected value is 1 because we have only one transaction with this. There it is, 1, right? So these are some of the intermediate operations that we wanted to cover. So we covered filter, we covered sorted, we covered limit, we covered string, we covered find any, we covered this mapToInt, some of the intermediate methods. In the next lecture, we'll go ahead and cover more advanced, intermediate, and terminal operations. There are many more terminal operations which I would like to cover, but we'll do it in the next lecture. All right. Thank you for your attention. I'm going to upload this code on my GitHub repository. If you just want to take a look at it, download, play with it, update, change, give all the values, different methods, try it out. All right. Thank you. See you all again in the next lecture. Bye.